Before we solve this integral, let's step back and understand what integration actually represents. Many students think integration is just a formula, but it is much more than that. Integration is essentially the reverse of differentiation. When differentiation gives us the rate of change, integration helps us recover the original function. Think of it like tracing back a path you took, given your speed at each point. So whenever you see an integral, remember, we are trying to find a function whose derivative would give us the integrand we see. This mindset is crucial and will make even complicated problems easier to understand. Another important idea is the linearity of integration. This means if we have a sum or difference of multiple terms, we can separate them and integrate each one individually. This is extremely helpful because it allows us to break a complex problem into smaller, simpler pieces, reducing the chance of errors. Think of it like cooking a recipe. If a dish has multiple ingredients, you can prepare each ingredient separately and then combine them at the end. Similarly, integrating each term separately makes the process manageable. Now let's apply this linearity to the given integral. The integral contains three terms, 3x squared, minus 5x, and plus 7. We separate them into three separate integrals, which we will handle one by one. By splitting the integral this way, we reduce the original problem into three simpler tasks. This is always a useful strategy when dealing with polynomials or any sum of terms. Next, we recall the power rule of integration. This is one of the most important rules for polynomial integration. The power rule says that when you integrate x raised to a power n, you add 1 to the power and then divide by the new power. Mathematically, it's written as integral of x to the n dx equals x to the n plus 1 over n plus 1. Remember, this rule works for any real n except minus 1. Think of it as reversing the process of differentiation. If differentiation reduces the power by 1 and multiplies by the original exponent, integration increases the power by 1 and divides by the new exponent. Keeping this mental picture helps avoid mistakes. Let's apply the power rule to the first term, 3x squared. Increasing the exponent from 2 to 3 and dividing by the new exponent gives us 3 times x cubed divided by 3, which simplifies to x cubed. This step demonstrates how coefficients can cancel during integration. Notice how the 3 in the numerator and denominator cancel, leaving a clean x cubed. This simplification makes the answer neat and easy to read. Now let's integrate the second term, which is minus 5x. Again, we increase the exponent from 1 to 2 and divide by the new exponent. Multiplying by the coefficient gives minus 5 divided by 2 times x squared, or minus 5 halves x squared. This shows how negative coefficients are handled during integration. The negative sign remains, and we apply the same power rule as before. Next, we integrate the constant term, 7. A constant does not change with x, so the integral is simply the constant multiplied by x. This is intuitive because adding 7 repeatedly as x increases gives a total proportional to x. Think of it like counting steps. If you take 7 steps each time unit, after x units, you have walked 7 times x steps. This analogy helps understand why multiplying by x works here. Now we combine all the integrated terms together. Adding x cubed, minus 5 halves x squared, and 7x gives us the complete indefinite integral, except for the constant of integration, which we will add next. Combining terms like this helps us see the overall structure of the integrated function before we account for the constant term. Finally, we add the constant of integration, c. This is very important because indefinite integrals represent a whole family of functions. The derivative of any constant is 0, so adding c captures all possible original functions that could give the same derivative. Always remember, the constant of integration is mandatory in indefinite integrals. It represents unknown starting points of the original function and ensures the solution is complete. Now we can write the final answer clearly and confidently. The indefinite integral of 3x squared minus 5x plus 7 with respect to x is x cubed minus 5 halves x squared plus 7x plus the constant of integration c. This is our required integral. Every term has been handled carefully, and the constant ensures all possible original functions are included. To conclude, let us remember the key steps from this problem. First, we split the integral into separate terms. Second, we applied the power rule for each term. Third, we combined the terms and added the constant. Following this systematic approach ensures accuracy and understanding. By always following these steps, even complex polynomial integrals become manageable, and students can build strong conceptual understanding.